In this video we're going to learn about another crucial communication component called the voltage-controlled oscillator. Voltage-controlled oscillators are elements that take a relatively slow-varying input called the control voltage and produce an output sinusoid whose frequency depends on the control voltage, which I've indicated with the notion f of v control, so that's the frequency produced by the control voltage, to indicate that it's some function. The amplitude is set by the oscillator and generally not controllable. The function f is called a tuning curve, and included an example tuning curve on the right. Tuning curves are generally very nonlinear, but it's common to approximate them as linear for small control voltage deviations, which leads to the approximation that the frequency is linearly dependent on control voltage. The slope relating voltage to frequency in this approximation is called VCO. There are many ways to make VCOs, but we're going to break them into two broad categories again. Ring oscillators, or other digital oscillators, are very easy to build. You just hook up a few logic gates, usually inverter, such that they're never satisfied with their internal state, which causes oscillation. Changing the voltage on the power rail of the logic gates changes how fast signals propagate through gates, and accordingly it changes the frequency of oscillation. The output signals from ring oscillators aspire to be square waves, though they're often going fast enough that they kind of get filtered. So they tend to have lots of harmonic content. LC oscillators are built using an LC network in feedback around an amplifier. If the feedback is designed right, the amplifier will be unstable, which will create an oscillation at the natural frequency of the LC tank. A variable capacitor called a varactor can be controlled by V-control to tune the oscillation frequency. The filtering properties of this LC tank make LC oscillator spectrums very clean, but they tend to be power hungry and tricky to design. So in summary, voltage-controlled oscillators have a frequency controlled by an external voltage, and they usually have a fixed amplitude. Tuning curves are nonlinear, but they're often approximated as linear. And ring oscillators make noisier spectra than LC oscillators.